Okay, good afternoon. I've got 1 o'clock on my watch, so we're going to get started here. Welcome to the FCA International webinar on OSHA's new Respirable Crystalline Silica standard for the construction industry. Before we get started here, I just wanted to remind everyone that the CREST Awards, last day to register for CREST Awards is March 3rd. So make sure that you register for the CREST Awards. Again, last day is March 3rd. If you're looking to register, you can register at esafetyline.net/FCA award. So that's esafetyline.net/FCA award. Again, March 3rd. So we'll get rolling here. A little bit about me. My name is Drew Page. I'm the FCA liaison to the International Safety Committee. I have about a little over 9 years experience with safety and health. 5 of those years were with a high-rise construction company downtown Chicago. The last about 5 years have been with Optimum Safety Management. We're a full-service safety and health consulting firm located out of the suburbs of Chicago. And at Optimum, our vision is to see workers everywhere valued and safe. So we're looking at partnering with our clients to see gains in productivity and safety results and best practices. So today we're going to be talking about silica. Not sure of everyone's experience with silica, but I have a feeling that, this is something that's been around forever. It's around us all day long. We've probably been exposed to it before, but maybe we haven't been thinking of all the hazards. And again, everybody on this line will be muted. At the end, we will not take questions. It just gets a little crazy unmuting everybody. But the safety helpline, FCA safety helpline, if you have any questions after this webinar or any questions at all, this is a free service to all FCA members. The International has set up this safety helpline. You can either email or call in, and we're looking to get you a response within 24 hours of you calling, all right? So any questions pertaining to this topic with the new silica standard, feel free to submit those through the safety helpline. Also, any questions that come up just related to safety and health throughout your business, feel free to utilize this as well. Okay, so this is what we're going to be going through today for the new silica standard. We're going to talk about the hazards and the history with silica, the scope of the new OSHA standard, exposure control methods, respiratory protection, written exposure control plans, medical surveillance, and record keeping. And then at the end, we're going to talk about, all right, this is great information, but what do I do now? All right, so what should your next steps be after this webinar to start building your program for compliance? Again, this is for the construction industry. So we're looking at 29 CFR 1926. The standard number is 1153. All right, there is a silica standard for general industry as well. It aligns itself very closely to the construction standard. However, there are some significant differences as well. So in a construction setting, that's what we're talking about here. Some other standards that are going to cross over into the compliance of the silica standard are your respiratory protection, access to exposure records and medical records, hazard communication, and if you're doing any abrasive blasting, there's specific standards for construction in that. So those are just some things to be aware of as well, where the silica standard, the new silica standard, will actually reference these standards. So you got to comply to these as well. All right. So a little bit of background here. About 2.3 million workers are exposed to respirable crystalline silica in the workplace. All right, so that's a lot of people exposed here. The majority are in construction. Okay, majority are in construction. So OSHA has a statistic out there that more than 14,000 workers in the U.S. have died from silicosis since 1968. All right, so they're saying about 200 workers die from silicosis each year. Now, one thing about these numbers are we know the construction industry that smoking in the past and probably still has been very prominent in the construction industry. So the fatalities from silicosis compared to smoking related isn't really, the lines are a little blurred there. All right. Most of them were smokers. So the question is, if they didn't smoke, would the silicosis have still killed them, or was it more of the smoking that had an effect? Both of them combined definitely didn't help anything. So just a quick video from OSHA's website.
And I feel it to be my duty to make this report available to the working people of the United States and to their employers. This report shows how silicosis occurs, where it occurs, and what the disease is. The report emphasizes that these control measures, if conscientiously adopted and applied, that silicosis can be prevented.
When I first seen Francis Perkins' video, I was just outraged that in 1938, 60 experts spent just a year to figure it out and to really make it simple. Turn the water on or turn the vac on. My dad was a sandblaster for several years in his late 20s. Shortly after that, he became short of breath. We didn't know what it was. He had a couple collapsed lungs. And then finally the diagnosis came, it was silicosis. It took about 5 years to kill him. And we got to watch. The toughest thing was watching him come home when he couldn't work no more. And literally fell on the ground and cried. He said, I can't do it no more. So the impact is huge. Anyone that's ever lost anyone knows exactly what I'm talking about, whether it's cancer or a sudden fall. But watching a loved one suffer is a real human toll. They didn't know then, and most people don't know now about the hazards of working around silica, dry grinding and cutting and polishing material that produces silica dust. The modern workforce can work safer. The silica standard can save lives. It will save lives. And frankly, it's going to save a lot of money. If over 50,000 people are dying every year from diseases they contract at work, some of them silica, imagine the cost. It's time to get the word out and let them know about this.
So that video again is from OSHA's website, and it kind of puts in perspective why this standard came about. All right, so OSHA has been actually pushing this standard for quite some time, and now it's here and it's here to stay. But hopefully that puts a little bit of perspective on it, because this is one of those things that, it's not going to hurt someone immediately today, right now, but maybe it's affecting them way down the line later on in life. we will talk about the beginning of that video, and we'll see that clip again here. He talked about in the 1930s where they knew about this, and we're gonna show you some more of that as well. So let's go ahead and look more at what is silica, the hazards, and a little bit of the history here. So what is silica? So crystalline silica is commonly found, and it's not naturally occurring. It's all over the place. It's in the ground, sand, concrete, stone. It's just all over the place. Now, amorphous silica is silica gel, so it's not crystalline. So moving forward through the rest of this webinar, whenever we refer to silica, we're talking about respirable crystalline silica, all right? There's 3 different types of silica. So the most common is quartz, all right? So this is found in the Earth's crust, and it's gonna be in all the rock that we're using. And then the other 2 are not found as much, cristobalite and tridymite. Those 2 aren't found as much. Mainly what we're looking at is quartz, especially in the construction industry. So, you know, anytime we're breaking up rock, grinding, blasting, drilling, crushing, even dry sweeping, right? We can kick up solid dust particles that are going to contain silica in them. The highly historical exposures are sandblasting. So some of you on today's webinar might be sandblasters. We'll be talking about that. That's a huge exposure. Mining, that's regulated by MSHA. Granite cutting, concrete cutting, a lot of different industries. Any products that contain greater than 0.1% of silica by weight or volume, they have to include that on the safety data sheet. So we're going to look at some examples of safety data sheets here today that are going to affect the finishing contractors. But if you're concerned or if you're questioning, well, is there any silica in this product, go straight to the safety data sheet. Again, greater than 0.1%, they have to list it on there. So it's going to be listed. So what are the hazards? What are the hazards? At the end of the day, it causes silicosis, which can turn into cancer. So we're talking about lung fibrosis. When we inhale the silica, this is non-reversible. Sometimes, yes, it's fatal, and we've known about it for a long time, okay? I'm going to show another video, and it's
silica. It's one of the most common substances on Earth. It can be found in materials like sand and rock, and building products like concrete and brick. When a worker cuts, grinds, or drills materials that contain silica, dangerous crystalline silica dust is released into the air. As the worker breathes, silica crystals flow into his mouth and nose, and down the air passages deep into the lungs. The tiny crystals enter the small, fragile air sacs, where oxygen is absorbed into the blood. Immune system cells, called macrophages, engulf and try to dissolve the crystals, but they are unable to. Over time, more and more crystals build up inside the macrophage cells. The macrophages carry the silica into the walls of the lung, where they die. Scar tissue forms around the dead cells and spreads as more cells die. This damage can continue even after the exposure to silica stops. Eventually, so much scar tissue forms that the lungs can no longer function. For information on how to protect yourself from silica exposure, visit.
So that was a great video showing how silica exposure happens and how the crystals get down into the tissue of the lung. So that was from WorkSafe BC. I thought it was a great video, but similar to if you're familiar with asbestos, right? Asbestos is fibers, but it gets down deep into the lungs and it damages and it creates scar tissue, right? Silica, instead of being fibers, it's crystals. So when you do see a dust cloud, right, what you're seeing, you actually can't see the crystals. Okay, so the dust cloud that, you know, maybe gets stuck on someone's face or kind of in their nose, you know, those thicker particles, those aren't the respirable particles that we're concerned about. They're too thick. So the respirable particles we're concerned about, we actually can't see. But it's a pretty good indication that if we can see the big stuff, the small stuff's definitely in there, and we're breathing that, and it's going down all the way into our lungs, where it's doing exactly what the video just showed. So I thought that was a great depiction of that. Your chronic or classical silicosis takes about 15 to 40 years of exposure. So working every day, a little bit of exposure throughout the 15, 40 years. Next thing you know, someone retires, they're going to the doctor does a chest x-ray because they're having tightness of breath, says, yeah, it looks like you have a lot of damage here, and it just gets worse and worse and worse. They develop silicosis, they develop cancer, and, you know, a year or two after retirement, they're passing away, right? Accelerated silicosis, 5 to 15 years of exposure, again, detectable by chest x-ray. So we can see this stuff in chest x-rays. So we're going to talk about medical surveillance in here at the end, and that does include chest x-rays, right? So OSHA is going to start requiring us that if our employees could be exposed to silica or are exposed to silica at over such a rate, we're going to be required to give them chest x-rays. We'll get into the details of that coming up here. Acute silicosis, this is 1 to 3 years of exposure. So we're talking about just massive amounts of exposure, like straight 8 hours in a day. It can happen. It can happen. And that would be a very bad situation. Definitely preventable. Hazards associated with silica. We talked about some of these already. Lung cancer, absolutely. Tuberculosis, autoimmune diseases, kidney diseases, stomach and other cancers, and the list kind of goes on and on. Some of the signs and symptoms. A lot of times there are no signs at the early stages. It's happening, and it's going to be irreversible, and we don't know about it, right? As it progresses, the tightness of breath, feeling weaker, coughing, that sort of thing, and then it is visible on a chest x-ray. A little bit of the history of the standard. So the first video we saw, they referenced 1938 as, you know, the Department of Labor knew about this in 1938. Yeah, they absolutely knew about this to the point where they produced, it's about an 11-minute film. I have a link to it here. We're going to watch about the first 4 minutes of it because I think it sets the tone very well that we've known about this for a long time. It's nothing new. We've definitely known about it for a long time, and it shows how small these crystals can be as well.
Silicosis was taking its toll from the ranks of American workers. Cause of the disease, dust. Results of the disease, disablement, poverty, death. Cure for the disease, none. Throughout America, workers exposed to dust grew fearful of their health, of their very lives. 1936. Amid these alarming events, the Secretary of Labor called together a national conference to study this disease. A committee of 60 experts was appointed, and a year later reported to the Secretary of Labor. But let's hear from Miss Perkins herself.
After a year of work, the National Silicosis Conference Committee has just made its report of findings and recommendations, and I feel it to be my duty to make this report available to the working people of the United States and to their employers by every available method. This report shows how silicosis occurs, where it occurs, and what the disease is, and it makes recommendations for its practical control. Above all, the report emphasizes that these control measures, if conscientiously adopted and applied, that silicosis can be prevented.
This is the story of silicosis, a disease of the lungs caused by breathing fine particles of dust containing silica. Granite dust. Its small particles consist mainly of free silica. The smaller the particles, the greater the danger to human lungs. Here is a fine mesh screen with over 100,000 openings to the square inch. Notice how readily the silica dust passes through. Yet this screen is so fine that it holds water. Every drop poured into the sieve is poured back into the glass. Here, dust particles taken from the air are being analyzed to determine workers' exposure. Granite dust, particles of which can enter a workman's lungs and cause trouble. This cross-section shows the nose and throat passages through which dust is inhaled into the lungs. The fine dust particles enter the lungs and settle in the terminal air spaces. Physical and chemical changes occur. Scar tissue forms. Small at first, these scarred areas grow larger as time goes on. This tissue is fibrous, tough, and inelastic, and the lungs cannot adequately perform their task of carrying air to the blood. As a result, the affected worker becomes so short of breath, he can no longer do his job. This magnified section shows the alveoli, or small air spaces in the lungs. They supply life-giving oxygen to the blood. Silica dust clogs these spaces and deadly scar tissue forms. This is the way a silicotic lung appears to the X-ray. The black areas are dead tissue.
So the video goes on to tell us to put engineering controls in place and mainly water and vacuum systems. So I'll stop it there, but how silicosis occurs, how they just described it to us from a video back in 1938 is very similar from what we just looked at. Just the visuals weren't as great, right? So 1938, we knew about this. The Department of Labor, they said if you take our recommendations, it can stop this. There was no OSHA at that time, right? So there weren't, and there weren't any OSHA standards. There weren't any laws for worker safety. Just the Department of Labor saying, yeah, there's this issue. We recommend you do something about it. So 1970, OSHA was founded, and they actually set a PEL, permissible exposure limit, for silica at 250 micrograms per meter cubed. So that's 250. So that's the number we've kind of been using since this new standard came out. Okay. Shortly after there, NIOSH recommended that they drop that to 50. OSHA never did anything. And then we see a bunch of dates here where every administration was trying to do something with silica. All right. They were either trying to push a new standard, or maybe they were trying to stop a standard, or stop the new silica standard. But what eventually happened is finally in 2016, this final rule came, and it takes effect June 23rd of last year. it was in effect June 23rd of last year. Now it's not enforceable right now, but June 23rd of last year is when this went into effect. So what are our compliance dates? All right, very important. June 23rd of this year, 2017, for the construction standard, we must comply, all right, with all requirements of the standard. There's an exception that relates to Appendix A of how laboratories are analyzing this, but that can be enforced a year following. But that is very minute compared to all the standards that are in here that we're going to start reviewing right now. All right, so June 23rd, right around the corner. So let's take a look at what we need to be doing. The scope of the standard, okay? Scope of the standard. So this applies to all occupational exposures for silica and construction work. The only exception is where the employee can say that under every foreseeable condition, we're not going to exceed the action level for this task. All right? So the employer has to make that determination that for any unforeseeable condition, we're not going to go above the action level. So what is the action level? The action level is 25 micrograms per meter cubed. All right. So the old PEL we talked about was 250. That new action level now is 25. Action, that's when I need to take action. And this is calculated over an 8-hour time-weighted average. So if we think there might be exposure, we have to prove that it's below the action level, and then the standard doesn't apply to us. The only way to prove that, in many cases, is to do air monitoring. How else are you going to know? We would need to do air monitoring. Now, if you don't foresee it being an issue, like the product I'm using doesn't even contain silica, I'm not even making any dust, I'm not doing anything that would create any silica dust, then okay. But if you are using a product, let's say that contains silica and you're cutting it and it could potentially become airborne, employees could breathe it, you don't know unless you test. Additionally, OSHA calls out a competent person. So we have OSHA calls out competent person for fall protection, for excavation. OSHA's calling out a competent person for silica. So this is the person that is capable of identifying existing and foreseeable hazards related to silica. And this is also the person that has the authorization to make corrective actions, all right? So the competent person has to be deemed by the employer, all right? Only the employer can say, you're my competent person. A lot of times this is placed on the foreman on set, okay? But at the end of the day, if you're saying you're my competent person, you're giving that person authorization to take corrective action. Now, if you're calling them your competent person, but you're not letting them take corrective action, then it's smoke and mirrors, and that's not going to hold weight. You really don't have a competent person. They also have to be educated and have the knowledge and understand the topic where they can identify existing and foreseeable hazards, okay? So OSHA calls out that this competent person must make frequent and regular inspections to job sites and equipment to make sure that the implementation of the written exposure control plans is accurate, all right? So we're implementing our written exposure control plans. So they say frequent and regular inspections. They don't tell you how often. And they're specifically saying implementing the written exposure control plan, all right? What the heck is a written exposure control plan? We're going to talk about that. That's specifically identified and detailed in the standard written exposure control plan. So let's talk about exposure control methods. So exposure control methods. First, we're going to talk about specified exposure control methods. So what I said earlier was, how do you know you're above the action level? the only way you know is you have to do air monitoring. All right. So what OSHA has done for construction only, they did not do this for general industry. For construction only, they gave us Table 1. And these are our specified exposure control methods. So Table 1 has 18 common tasks in the construction industry that are known to produce silica. So they've taken all 18 of these tasks and they said, if you're doing any of these tasks, for every specific task, here's the engineering control you have to use, here's the work practice control you have to use, and here's the respiratory protection you have to use. If you do it the way we outline it, then you don't have to do air monitoring and you comply through this specified exposure control method. Okay, so there's 18 common tasks. So again, fully and properly implement, and then your exposure monitoring or your air testing, you don't have to do it. So why would OSHA do that? Because they know that every job site's different. Construction is very dynamic. Things are always changing. It's not a manufacturing environment where at this station we're doing this, it's creating silica so we can test and put our engineering control in place and it's a done deal, right? For these 18 tasks, you'd have to be testing all the time. It would be maybe infeasible, put companies out of business, so they have these 18 common tasks. Now, OSHA is being sued by many industries, industry associations, labor unions over the standard. Does not mean the standard is going away. It's not going away. But there could be some changes. And one change that I have heard that could happen is that these 18 common tasks, this list could expand, because it's definitely not all-inclusive. There are many tasks that OSHA did not put in Table 1 that it would be nice if it was in there. So these 18 common tasks, there could be more down the road, but we'll just have to wait and see. So what are the tasks? So let's look at all these tasks, all 18 of them. So using stationary masonry saws. So right now would be a good time to kind of do an assessment in your head, or maybe be writing down, do we use stationary masonry saws? All right. If so, be writing that one down, because there's certain compliance for that. All right. Handheld power saws, any blade diameter. So handheld power saws. Handheld power saws for cutting fiber cement board. That's probably one that a lot of participants on this webinar are potentially doing. So fiber cement board, yeah, we know there's a lot of silica in that product. If we're cutting it, right, that's a task on Table 1. There's specific controls and specific respiratory requirements for that task. So we're going to want to comply to it. Walk behind saws. Drivable saws. Rig mounted core saws or drills. Handheld and stand mounted drills. So we're talking about impact and rotary hammer drills. So that's probably a very common task if you're setting anchors or anytime you're drilling concrete. That task is in Table 1. There's specific requirements. We'll look at an example of these specific requirements when we're done looking at all 18 tasks. Dowel drilling rigs, vehicle mounted drilling rigs, jackhammers and handheld pit chipping tools, very common. Handheld grinders for mortar removal, so tuckpointing. And then we have handheld grinders for other tasks other than mortar removal. Walk behind milling machine and floor grinders. small drivable milling machines, large drivable milling machines, and crushing machines. And then our last two is heavy equipment used to fracture silica-containing materials, so like doing demolition activities, and then heavy equipment for non-demolition activities, so grading and excavating. Okay, so those are your 18 tasks. So you might be sitting there thinking, well, what about this, this, and that? And we're going to cover those as well, but those are currently the 18 tasks. So let's look at it. One common task is with the rotary hammer drills. And this is what OSHA is saying specifically for rotary hammer drills, what we have to be doing. All right. So we need to use a drill equipped with a commercially available shroud and dust collection system. Have to operate the tool in accordance to manufacturer's instructions, and the dust collector must provide airflow recommended by the tool manufacturer and have a filter of 99% or greater efficiency. And we also must use a HEPA filtered vacuum when cleaning the holes. Okay, so you can see a great example of that on the upper right hand corner where this drill actually has an attachment on the side of it where it's going to collect all the dust. Another option here, you can see that there on the bottom picture, there's a hose that's going to a portable vacuum. That's another option, right? So if we're doing that, and then they tell us what kind of respiratory protection do we need. Less than 4 hours per shift, they're saying we don't need any respiratory protection. Greater than 4 hours, again, they're saying we don't need respiratory protection. So whenever we're drilling holes, we need a commercially available shroud and dust collection system. If we're not going to do that, then guess what? We have to do air monitoring to prove that we're below the action level. So this would be something, if you're doing a lot of drilling, we should start looking at commercially available shrouds and dust collection systems for our impact or rotary hammer drills. Another common task would be jackhammer, and this is just another example. Here they're actually giving us two options for engineering controls. They're saying use a water delivery system that supplies a continuous stream or spray of water at the point of impact. So the old school way of someone else standing there with a hose and the other person doing the jackhammering isn't going to work, because we always know that that person with the hose turns around, walks away, disappears for a couple hours, things dry up. All right. So it actually has to be part of the tool having a continuous stream at the point of impact. Or they're saying, okay, you're working indoors, you can't use water, use a commercially available shroud and dust collection system. So you're going to see that example in the upper right-hand photo. Respiratory protection's a little different for this one. They're separating out from indoors and outdoors. So if you're using the jackhammer with the engineering control in place and you're outdoors for less than 4 hours, no respiratory protections required. Greater than 4 hours, we need an assigned protection factor of 10. So what is assigned protection factor of 10? Your filtering face piece respirator, commonly referred to as the dust mask. So that has to be NIOSH rated. N95 is a great example. So a filtering face piece respirator, that has an assigned protection factor of 10. Also, a half mask respirator has an assigned protection factor of 10. Full face respirator, we're looking at, that bumps up to 50. Anytime you're working indoors or in an enclosed area, OSHA doesn't care how long you're going to be doing this particular task. Jackhammering, use the engineering control, and you need the assigned protection factor of 10. So they're going to be requiring the respiratory protection at all times at that point. Again, if we fully implement and fully enforce and fully comply with what is laid out here for jackhammers, then we don't have to test. If for some reason we say we can't do that, then we're going to have to test. Even if we say I can't do those engineering controls, I know I'm going to be over, so I'm just going to throw my employees in a respirator. You're not going to be able to do that. You're going to have to test, show the levels, and assign the proper respiratory protection. Okay. So some other considerations when implementing Table 1. We have to minimize the visible airborne dust. All right. Whenever we're in enclosed areas, we have to have some kind of means of exhaust. So if I'm indoors jackhammering and I have my vacuum control and my respirator on, but I'm still creating a visible dust, I have to figure out a means of exhausting that, right? And then anytime we're using wet methods, we have to apply proper flow rates to make sure that visible dust is eliminated or minimized. Anytime we have an enclosed cab or booth, there are some other requirements with the door seals and the gaskets and everything closed up, positive pressure, heating and cooling capabilities, that sort of thing. So that was our specified exposure control methods. We also have alternative exposure control methods. Okay, so this is if we don't have a task on Table 1. Well, the task I'm doing isn't listed on Table 1, right? Here are some examples. We saw a lot of concrete cutting tasks, but they never specifically called out a track-mounted wall saw, wire saw, hand mixing mortar. Are there others? There are numerous others. We're going to look at some in a little bit specific to the finishing industry. All right. So if your task isn't on Table 1, you have to do an alternative exposure control method. Or when Table 1 isn't fully and properly implemented. Well, I can't use a vacuum and I can't use water. First of all, OSHA is going to say, prove to me why it was infeasible, right? And then the employer bears that responsibility to prove that infeasibility. And then additionally, once it's infeasible, I can't fully and properly implement Table 1. Now I have to use my alternative exposure control methods. So what are my alternative exposure control methods? Well, now I have to prove that no employee is going to be exposed over the new PEL. Permissible exposure level, we said the old one was 250, the new PEL is 50 micrograms per meter cubed. Again, over a 8-hour time weighted average. So how do I know if employees are exposed, right? We're going to have to do some air monitoring. So the levels, they have to be assessed for each employee at or above the action level, which our action level was 25. We have 2 ways to do an exposure assessment. We can do a performance option or a scheduled monitoring option. So scheduled monitoring is going to be our air monitoring. Let's look at performance option real quick. So this could be any combination of air monitoring data or objective data that can accurately characterize our exposures. All right, some examples would be air monitoring data from an industry-wide survey. Now we need to be careful there. Any past industry-wide survey is going to be tested according to the old standard and the old laboratory requirements, and none of that would be adequate for what we're doing here. All right. Additionally, if you're going to use industry-wide surveys, you better make sure that that task is being done from that survey the same way you're doing that task in the same conditions. Maybe that was tested outside, but you're working inside. Maybe that was tested with only one employee doing the task, and you have 10 employees doing the task in one area. So your exposure may be more. So performance option here can get a little dicey. I would highly recommend that for all initial monitoring, absolutely we need to do our scheduled option, right? So scheduled option. So this is our air monitoring samples, and they need to reflect the appropriate exposure for our employees for each shift, each classification, each work area, right? So pretty much what you're looking at is sampling an adequate size. Industry standard tells us at least 25% of your employees exposed or conducting that task, and then selecting, your worst case scenarios. So again, if you're doing this task primarily inside, you don't want to go test someone doing the task outside. You're going to get totally different results. You're going to want to get your worst case scenarios. Again, our action level is 25 and our PEL is 50. So once we do our scheduled monitoring, our initial testing, if it's less than the action level, we have that documented and we're showing, all right, now the standard doesn't apply to me, because we said the only exception for this standard not to apply to you is that we're below the action level. And if we can prove that through air monitoring, then it doesn't apply. And everything we're talking about here for that particular task would not be included in the new. You don't have to comply to the standard. Okay. If we're at or above the action level but below the PEL, then for that task we need to repeat monitoring every 6 months. And if we're above the PEL, we need to repeat monitoring every 3 months. So what OSHA is trying to do here is trying to force you to come up with more engineering controls, and hopefully over time we're putting more and more engineering controls in place where we're reducing the levels to, it'd be nice at some point to get below the action level. All right. Once we got below the action level, we have to have 2 consecutive results below the action level, and then we can discontinue monitoring. So if I go back here, this is the scheduled monitoring option. We also talked about our performance option. So you might be in a situation where your initial monitoring for a task, let's say sandblasting, because that wasn't on table 1, and you're doing so much of it, and you're monitoring you're above the PEL, and you're monitoring 25% of the workforce doing that every 3 months. Over time, I'm using the same abrasive, I'm hitting the same surface, I'm always outside, and this is all my data that I've collected. We have all the engineering controls in place. This thing isn't moving anymore. You may at that point be able to shift to a performance option saying, this is all my air monitoring data, my objective data, where I'm coming up with, this is it, and it's not going to change, right? But absolutely for our initial, we need to use the scheduled monitoring. Additionally, if there's ever a change in production, process, equipment, anything, then we got to go start back from the drawing board, right? Because we're starting to use a new aggregate, we're starting to use new equipment, we're starting to change things instead of, working, maybe in the winter we're in closing areas. That's going to change it. That's going to change everything. So we need to test for all those changes as well. So something to keep in mind. Observation of monitoring, you need to provide affected employees or their designated representative with an opportunity to observe the monitoring. So OSHA calls that in a standard. And then we need to notify the employees within 5 working days of the results. All right. We need to notify them of the results and what we're going to do because of the results. If anything's above the PEL, we need to notify them of that and let them know this is what we're going to do to drive it down or to protect you. So what we've done as a task group within FCA on our safety calls is we've had everyone kind of brainstorm what are some tasks throughout the industry and the different sectors where we could be exposed. And what you see here is everything in red is not on table 1, right? So for flooring contractors, shot blasting concrete floors, for industrial coatings, any abrasive blasting, painting and wall covering, what about plaster repair, right? Drywall, staining drywall compound, mixing joint compound. We didn't see that in table 1, all right? All trades, what about just general sweeping, okay? Existing site conditions, so this is gonna be a big one. This is gonna be a big hurdle for general contractors to tackle, right? They're in charge of general conditions, all right? What if we're on the site where it's a gravel site and it's a dry, windy day and it's picking up and it's blowing into the building? We're going to have exposure there. So those are some things we're going to start having to think about. Additionally, if we're looking at these safety data sheets, like I said, anything greater than 0.1% silica has to be on the safety data sheet. So I just pulled some safety data sheets. This is just one for drywall, which this kind of shocked me. I think they just changed this recently because I believe last time I looked at it, they were recommending for you to test, but they're saying that the silica is ranging up to almost 0.5% by weight. So they're calling it out like they're supposed to. But then they go on to say industrial hygiene testing using both personal and area sampling measured no detectable respirable silica when cutting the product by score and snap, rotary saw, or circular saw. So I thought that was pretty interesting that they're going to take that much ownership on that. We need to be looking at the safety data sheet. What are these things saying for all the products that you're using? Here's a totally different story, right? So joint compound, right away on here, what draws your attention? They have the guy in the middle with the exploding heart, right? So we know that's respiratory hazard. Hazard statement on it says may cause cancer by inhalation. It's going to go on to have a lot of comments on silica. Exposure to silica during normal use of this product may be determined by workplace hygiene testing, so air monitoring. So they're telling you, we don't know, you got to monitor. But it is also saying that it's less than 1% silica containing. Still don't know what the exposure is. Again, they're going to call it out in multiple places that silica could cause silicosis or lung cancer. Prolonged use can lead to lung disease. All right, so we need to be looking at the safety data sheets. We need to get a plan in place. How are we going to assess what our exposure levels are? So let's look at some methods of compliance, right? So OSHA is requiring us to use engineering and work practice controls to reduce or maintain exposures below the PEL. All right, we can't say I'm above, no big deal, I'll just put everyone in a respirator. All right, you have to demonstrate that these controls aren't feasible. So again, they want you to keep putting your controls in place. They want to force you to keep monitoring. So hopefully you drive the levels down. If all feasible controls are in place and we're still above the PEL, all right, we obviously need respiratory protection. But if we put all feasible controls in place and we're still above the PEL, we can't say, well, the heck with it, I'm not going to use these controls because it didn't get me below the PEL. Again, they want to reduce that exposure as low as possible. And we absolutely have to implement the proper respiratory protection. So this is just one example of an engineering control that I thought was pretty creative. And through this standard, manufacturers are going to start developing stuff like this. But this is a hollow drill bit by Hilti that this connects up to your vacuum. So as you are drilling, it's sucking all that dust out and you don't even have a mess. Now, Hilti originally developed this because the cleaning process of the hole to epoxy rebar in wasn't being done right. So they developed this where you don't have to clean after that. You can just epoxy. Now it doubles great as an engineering control. There's also some power saws out there that have a dust collection system in them. Housekeeping. So OSHA is telling us that we cannot dry sweep or dry brush. All right. And that we cannot use compressed air to clean. So we're talking about cleaning off clothing and cleaning off surfaces. We have to use either wet sweeping, floor compound, HEPA filter vacuum, that sort of thing. Respiratory protection, where it's specified on table 1, we have to implement it, or anytime we're over the PEL, we have to implement proper respiratory protection per 1910-134. Okay, so you have to have your medical clearance and your training and your fit testing and proper cleaning of respirators, proper storage requirements, go on and on. You got to do that the right way. Written exposure control plan. Okay, for all tasks where we have exposure to silica, right? We need an exposure control plan. So think of this as a job hazard analysis for silica. All right, it's a job hazard analysis for each task that's going to create silica. Okay. Again, the only exception is if we're below the action level, then we don't have to do this. So every task we're doing on table 1 needs a written exposure control plan. Every task that we're testing for and we're over the action level needs a written exposure control plan. This is going to describe the task, describe what engineering controls we're using, what work practice controls are PPE control, respiratory protection. It also has to include housekeeping measures and procedures to restrict access to work areas. Okay, so this is an example right off of OSHA's website of what a written exposure control plan should look like. Again, a JHA for silica. So this is part of the standard. If we're not doing this, we can get cited by OSHA. So this is something we definitely need to have in place. And our employees need to have access to it. So, hey, I'm going to go do this task. They're referring to this. They're doing it the right way. Respiratory protection, housekeeping, procedures to restrict access. All right. Written exposure control plans, they must be reviewed and evaluated at least annually. So that's a standard, right? If we're not showing documentation of annual reviews, we could potentially get cited. Must be readily available to each employee. And again, that competent person, they need to make frequent and regular inspections to make sure we're implementing this. So they don't call out how many inspections or how often, they just say frequent and regular. But they definitely call out annual reviews of the written exposure control plan. So medical surveillance, who's included? Any employee who's required to wear a respirator for 30 days or more due to silica exposure. So if table 1's calling out respiratory protection and we're putting that person in a respirator, and if table 1's calling out assigned protection factor of 10, you're using a filtering facepiece respirator, you're still using a respirator, it counts. So anytime we're wearing that respirator for 30 or more days in a year, that employee has to be a part of the medical surveillance program. At no cost to the employee, available at a reasonable time and place, and performed by a physician or other licensed healthcare professional. So you'll see this throughout PL, HCP. All right, we need to do initial examinations. That's going to include what was the employee's medical and work history. So they're going to have to fill out some documentation and give it to the doctor so he knows. They want to know their past exposure to silica. They want to know their history of respiratory system, if there's any issues, history of TB. What is their status on smoking? They're going to do a physical exam. They have to do a chest x-ray, and that needs to be interpreted by a NIOSH certified B reader. All of this costs money. Pulmonary function test, testing for latent TB, and any other test deemed by the doctor. All right. So this is, again, out of the standard, right? This is a big deal. So this is initial, and then periodically we need to be testing every 3 years or more frequently if recommended by the doctor. So if the PL HCP says, I want to see you every year, they got to go back every year. There's certain information that the PL HCP needs to provide to the employee, and there's certain information that they need to provide to the employer. All right. Information communicated to the doctor, though, again, all of this communication is the employer's responsibility that this gets done. All right. So we need to tell the doctor the description of the employee's former, current, and anticipated exposure. So we got to figure that out. We need to tell them what kind of PPE they're going to be using. We need to tell them any other medical records. So we better have a good form in place and good procedures in place for that employee to go to the doctor where they're bringing this information. Information back to the employee, again, is the employer's responsibility, except the employer can't look at that information. So they have to have a method set up where the doctor is certifying that they gave the employee this information within 30 days. Results of their exams, right? Recommended limitations on use of respirators. Recommended limitation on exposure to silica. Results of the x-ray. If they need further evaluation or further treatment. That's what they have to tell the employer, or I'm sorry, the employee, but it's the employer's responsibility that the employee gets this information. Now, what the employer must receive, again, from 30 days is, what was the date of the exam? Did the exam meet the standards? And any recommended limitation of respirators. So that's it. Doctor's going to tell you, this was the date, I did everything, I did all the tests that the standards require, and there either are limitations to respirator use or not. So the doctor cannot tell you without the employee's written authorization if they have to be limited, have limited exposure to silica, if they have onset of silicosis, if they have other issues going on. They can't tell you that, which is kind of crazy because that's going on. You want to limit their exposure to silica, but OSHA also wants to protect the employee where there's no discriminatory action where now they can't do their job anymore. So it's kind of interesting how this is going to play out. Additional examinations must be handled in the same fashion. Record keeping for air monitoring, any objective data, any medical surveillance, all of that must be kept in accordance to 1910-1020, which pretty much says you got to hold on to all this stuff for 30 years. So what do I do now? What do I need to do now that I just absorbed all this information? It's a lot. Trying to comprehend it. Where do I start? So first and foremost, your company's going to need a corporate silica safety program, pretty much outlining this is how we're going to comply to the standard, and pretty much showing compliance to the standard, all right? So that has to happen at some point, all right? Main thing is you need to conduct a silica hazard assessment. So you need to start talking to your employees, to your superintendents, to your foremen. Where do we have exposure to silica? Where could we be exposed to silica? What tasks are we doing? What general conditions are we exposed to? And start making a list of what are these items. All right. Next, you want to say, all right, are any of these items on table 1? If so, let's start looking at what are the specified engineering controls table 1's giving us. What's the specified respiratory protection? Let's get plans in place to make sure we have the required equipment, required respirators, and we get all that underway. Next, what are all of our tasks that aren't on table 1? All right, now I'm going to have to do air monitoring for these tasks, right? So we're going to have to get that set up. Again, when we're air monitoring, let's say for blasting, if we're using 4 different blasting aggregates and all 4 of them have silica-containing material in them, we're going to have to test for all 4 because the levels could be different. Also, what is the material you're blasting, right? If it's silica containing and your abrasive isn't, you're going to be hitting that and it's going to be throwing off silica as well. So we need to take all of that into consideration, and we need to test all our different scenarios. So we're complying to table 1. We've done our air monitoring. We know where the levels are. We know what engineering controls we need. Now we need to write those written exposure control plans for all these tasks that are going to affect us, specifying exactly how we're handling them. You need to train your employees on the new standard and the exposure control plans, right? So we're putting this exposure control plan together so they can comply to it. Obviously, we need to train them to it. That is part of the standard. We need to train. Set up a record-keeping system if you don't already have one in place. And then we need to start our initial medical examinations. We need to be looking for that designated competent person. We're annually reviewing the effectiveness of our written exposure control plan. Depending on our air monitoring, maybe we're monitoring tasks every 3 months, maybe we're monitoring them every 6 months, right? And we're continuing to do our medical examinations every 3 years or more frequently if recommended. So that concludes the webinar for the new silica standard for construction. I'll end this on the helpline because you're going to probably have some questions, and I want to get you the helpline number and email when those questions do come up. Just as a reminder, FCA has a toolbox talk program that you just need to contact International, and you get that for free. All right, it's about $800 a year value. So if you're not currently doing toolbox talks, this is a great way. Be looking out for the monthly safety bulletin. We've been covering this new silica standard. We've been covering the changes to the record keeping. We've been covering a lot of good things, so be looking out for that. If you haven't seen them, or you've seen them and you haven't read them and you want to go back and find them, they're also on the International's website. There's an archive of all of them. And again, the safety helpline, any questions pertaining to anything occupational, health and safety related, especially for silica, feel free to shoot an email over. You could also call. If you're interested in getting a copy of this presentation, multi-slides each page on PDF, send an email to safety helpline at finishingcontractors.org, and we'll get that over to you. And then the last reminder here, again, Crest Awards, last day to register is March 3rd. And you can register on esafetyline.net/FCA award. So that's March 3rd for the Crest Awards, esafetyline.net/FCA award. Thank you everybody for your time, and have a great rest of your day.